All right, good morning, gang. Welcome to a crash course in latitude and longitude, specifically some major lines of latitude and longitude, and this idea of a global grid and how we can use latitude and longitude to locate absolute location. So we're just going to start off here. We've got my lovely little sketch that we have here, and as we take a look at it, here is our Earth, and our main line of latitude here at 0 degrees is the equator. And so blank measures the distance north or south of the equator. That would be latitude lines. And so we see right down here by the equator at 0 degrees, it's probably pretty hot there, right? The closer you get to the equator, generally speaking, the hotter it's going to be. And the further you get away from it, the further north or the further south, the colder or chillier it's going to be. And so we've got our sweating dude over here. Gross. And then the latitude line right there, the equator, it separates our world into two halves. And I've got my globe here, that you can kind of see kind of our three-dimensional view. And we've got our equator that rolls around our globe. And it separates it into a northern hemisphere. Here we have our compass, and it separates it into the northern hemisphere right there. And then opposite of the northern hemisphere, then, of course, would be the southern hemisphere. The United States, North America, we're mostly located in the northern hemisphere. And so you just kind of think half, hemisphere, sphere, half of a sphere. So there again, that equator separates our world into a northern hemisphere and a southern hemisphere. And then in addition to the equator, we've got some other lines of latitude, and they just keep going up 50, 30, 60, and then up top at the North Pole, that would be like 90 degrees latitude, and then down at the South Pole, that would be 60 degrees latitude. And so you've got a couple of blank circles on your notes handout there. You're going to probably want to go ahead and maybe fill in some of these little diagrams and sketches as we go. So I'd encourage you to pause, rewind, all that good stuff. It doesn't need to be precise or exact, but just as long as you're getting the key concept. And so this idea here of the equator, like I said, we've got these lines or parallels of latitude. Notice all of these lines basically run parallel to one another. And once again, if we were to look on an actual globe, I know it might be a little bit tougher to see, but we can see our lines of latitude and how they run parallel to one another. And so here's just an overlay map of the United States. You can just kind of get a feel for these lines. And notice on this map here, they don't actually, they're not straight, they're not flat. And that's because, again, our world, it's not straight, it's not flat, it's round. And so when we try and take that round world, that spherical world, and we flatten it out like that, you need to kind of draw these lines with a bit of a curve to them, a little bit of curvature. But again, they are called parallels because they never touch, right? Parallel lines, you know this from math class, no touching. There again, the equator will never, ever, ever, ever intersect with, say, for example, 10 degrees north right here, or 10 degrees south right there. They never interact. They're parallels of latitude. Here again is just kind of another view that we can take a look. We've got our equator, and then we've got a couple of other key ones like the Tropic of Cancer, or the Arctic Circle, or the Tropic of Capricorn and the Antarctic Circle. And down here on the Capricorn side, of course, we have the capybara. Look it up, and the poop emoji will make a little bit more sense to you when you look up the capybara. But again, so we've got the equator that runs right through the middle, dividing into the northern half and the southern half, northern hemisphere and southern hemisphere. So, fun fact, we'll talk a little bit more about this, but the opposite seasons in the northern and southern hemisphere. So when it is summer in the northern hemisphere, it is winter in the southern hemisphere. Right now, when it is fall in the northern hemisphere, which we happen to be transitioning into, that means the southern hemisphere is transitioning into summer. And I know what you're thinking. You're going, wait a second. So that means up ahead, we have winter coming up ahead in the northern hemisphere, and the southern hemisphere will move into summer. And so while it is our cold winter on, say, December 25th, when it's Christmas, and a lot of folks are celebrating Christmas, and it's winter in the northern hemisphere, they still celebrate Christmas in the southern hemisphere. It just happens that December is a summer month when you're down under in Australia. Think about that. Kind of wild, right? So as we enter into fall, where we pumpkin spice everything and our leaves are changing, what season does that make it in the southern hemisphere? If it's fall in the southern hemisphere, it is springtime. So those are our lines of latitude. Now we also have our lines of longitude. Our lines of longitude, they run vertical, right? They go from the North Pole down to the South Pole. And you can see my map here, even though it looks a bit like a pumpkin. It's kind of a tough one. But they, just like our sorry, just like our main line of latitude is the equator, our main line of longitude is the prime meridian, and that goes from the North Pole all the way down to the South Pole, and that is technically, that is 0 degrees. So just like our line of latitude at the equator is at 0, we also have, let me see if I can pull this up here so you can see it. We also have, there we go, it's a little tough to do, but we have our main line of longitude, which is known as the prime meridian, and that also runs at 0 degrees. And so you can go west of the prime meridian, going this way. Well, it's kind of tough to do, but going this way, or east of the prime meridian. So lines of longitude is typically what we call them, but sometimes they're also called meridians, which is just a fun, fancy word, but that's also why we have the prime meridian. And notice these lines, they all intersect, they all touch together at the poles. So just if parallels never touch, our lines of longitude, they all intersect right here at the North Pole, and then again at the South Pole, down underneath. A lot of penguins down there. So here it is again, our prime meridian. That is our main line of longitude. It runs through a little town in England called Greenwich. I know it looks like Greenwich, but it's Greenwich, England, and that is our prime meridian. The opposite side, so you might be wondering, okay, so, and this is just kind of another little fun fact. So if here we have our prime meridian and it's running through Greenwich, England, then on the other side of the world, because that line, there's got to be something on the backside, if we flip that around, our other side of the world, that is called the international dateline, and that one is actually at 180 degrees. Now, I know what you're thinking, international dateline. I've got a pretty wide open social calendar this Friday. Can I hang out in the dateline and get myself a date? You probably weren't thinking that. I don't even know why I put that joke out there. But that's basically the other side of the world, the international dateline. You think about the sun, it's up in the sky. Right now, for example, here in Minnesota, it's 7:40 a.m. Central Standard Time. But out, if you were to go to Denver, Colorado, it's actually 6:40. If you were to go to LA, it's 5:40 in the morning. Honolulu, it's probably like 3:30 in the morning. I don't know, 2:30 in the morning. And then eventually you're going to kick it on over to the other side of the world, and the time's going to change. And when the time changes, the day changes, and the date changes. So if you want to time travel, just cross over to the international dateline. Anyway, I digress. Moving on. Like I said, our prime meridian, it gives us our western hemisphere. That's where we have our continents like North America. And here again, we'll kind of bring up a little globe down here in the inset. But we have our northern hemisphere, so that's mostly North America. And of course, South America, mostly in the Western Hemisphere. And then everything else is in the Eastern Hemisphere, Asia, Australia, Europe, Africa, all almost entirely in the Eastern Hemisphere. Not entirely, but almost entirely. All right. And so that kind of brings all of this together. Latitude and longitude, it gives us a set of coordinates. It gives us our absolute location, right? You have a degree of latitude that takes us one spot, and you have a degree of longitude, and that takes us to another spot. Latitude should always come first when you're giving these coordinates. Latitude should always come first when you're giving these coordinates. I will say it again for the people in back. Latitude should always come first when you're giving your coordinates. After all, you wouldn't call it a jelly and peanut butter sandwich. That's just weird. It's a PB&J, not a J and PB. Don't do that. So, for example, if I wanted to talk about 77 degrees north and 127 degrees west, basically what that is, you start at the equator and you go north to, essentially 77 degrees. And so you just kind of kick on up all the way up until you get to about 77-ish degrees, which is way high up there. And then you got to find 127 degrees west. So you find your prime meridian, and then you go west till you get to 127 degrees west. And that's also going to be way out up there. And so 77, 127, we're talking like way up here in like northern Canada, eh? Anyway, so those are just kind of a couple of key details for you about latitude and longitude, a quick overview. Now that you have all of that and a little bit of background, I would encourage you, well, no, definitely, you're going to want to move on into the map skills video where I do a quick recap of all of this and then actually show you how to use latitude and longitude. Hope you're doing well. Talk to you later. See ya.